Okay, I can start. Okay, hello everyone. I'm Michael Raskin. I will tell you about QueryFS and how I integrate between Common Lisp world and Unix world. And I will try to make a case that sometimes you want to do something similar to, at least some of you. So maybe a bit of a disclaimer and also of what it is all about. So what it is all about at QueryFS is a tool that allows you to create a file system defined by whatever kind of queries or code you want, and it is virtual file system with which applications can interact. Of course, as the main part of the disclaimer, while I care about this and why I expect and hope some of you would care about this is a bit different. And so, well, my examples, please take them as examples what can be done and do not put too much expectation that you want literally this. So I think that Common Lisp is a great tool. I like using it. I like using it in many contexts, although, of course, nothing is perfect. And, of course, Common Lisp also is not absolutely perfect. On the other hand, I can say the same as a bit of a disclaimer about POSIX shell scripts. I can say the same about structured query language. I can say the same even about Unix process isolation in some contexts where it fits. I want to use what fits where it fits and have freedom to do this. But the tool I'm talking about is in Common Lisp, but Common Lisp is a great thing, a great tool, but doesn't define every choice in this. And actually, I even use Vim, and maybe when I will show text fragments, you will notice that it is Vim and not Emacs. But my point is that it is integrating with the tools which are not fully part of your environment. I will also show that, well, okay, you can seek Firefox on it or something. So sure, maybe you want some of the things I want this way, you want them in Emacs. But probably you have things that you have to do in something broken, like a browser, and so there maybe the integration could be nice. So for me, I can admit that initial goal was to get something which allows me SQL as file system, SQL defining file system, better than RealFS did back in the day. For you, I want to say that if it is flexible enough to easily implement the SQL as file system, if you don't care about this, throw away the SQL, and there is still a lot left that you might want to imitate or even reuse parts of it. Okay, so as an overview of what it technically is, so it is virtual file system. It is implemented by Fuse file system in user space. It is a layout defined by code on the fly, and you can even update the queries on the fly. The queries are done in pluggable DSLs, and you probably don't fully agree with me on design on the DSLs, but it's easy to design and plug your own. And yeah, so I use it as SQL query as a directory, but really you can use it for whatever Lisp data structure as a directory. Okay, so now time for some demo, and for this I have backup slides, but maybe I should just show it live. So this is a bit of weird code using some macros I have defined specifically for QueryFS. So you can notice, it looks at the arguments. It tries to parse its argument, at least the first part of it. If it succeeds, it just say, okay, increment it. If it fails, it for some reason returns 10 different pairs of n plus 1. And then it knows that it can take the pair, you use the first part as the name, and the second part as the content, and it's all weird, but like, okay, let's see. So as I said, let's take whatever, let's take a browser. So we go to +1, and you can see that in the +1 you indeed have files from 1 to 10, and you can ask what is in the file 8, and you see that in the file 8 is 9. But okay, we are in the browser. We all know that we can edit URLs and see what we are not supposed to see, right? So we know it's 1 to 10. This shouldn't exist, right? No, it exists, because when we try to open the file system knows what file we are asking for. And as you have seen, it tries to parse its first, it's the name it's requested, if it is given a name. Because for listing, it's not given a name. It sees just nothing. It tries to parse, then it is given a name and do something. And if we do something like that, if it cannot parse and it is not from 1 to 10, well, then of course it is file not found. Natural, right? On the other hand, yeah, maybe you want a bit more than just +1. So I promised something about SQL. But OK, so let's do something about SQL. So yeah, so you have here, so let us select name and content from some test table. And then let's say that when we read, take the index 1, so the second part of whatever we selected. The 0th part is always the name. And also, we should be able to update things. And also, we should be able to remove things. And also, we should be able to create things. OK, so yeah, so if we go here and we go to all, indeed, there is a file 1, 2, 3. Indeed, there is ASD written here because I was just playing and put something there. Let me try. On the other hand, OK, let's write it to something else. Let's create another file. And if we look now, we see that, OK, we reload. Now there is the other file. We have sent to it ASD, so it is there. And if you look at the SQL table, then everything has been updated in the SQL table and whatever. So you see that if you browse it in Firefox, it's just normal file browsing. And on the background, I have written either some code or some SQL to show things. OK, so yeah, this is basically the same stuff. OK. So I have shown what it can do, that it can also do cheating, like create a file just on the fly when you requested it. And so what it has as the moving parts. So as moving parts, it has CLFuse, the lowest level. So it's use CFFI to rope the medium level Fuse API, and I will tell why exactly middle level. And then it has a lot of callbacks, and it has a slightly more Lispy wrapper to define these callbacks. But basically, it's just API wrapper. Then there is the MetaFS, which takes CLFuse and tries to be actually more Lispy a bit. So instead of let's define a ton of callbacks, let's write macros that kind of define, make a directory, make a file, and stuff like that, and generate if necessary. This is what I have shown first with this +1 example. And yeah, it is a set of macros to define layouts. What is missing is something more object-based. And to be honest, it's mostly missing because, as you have seen with the SQL example, this is not really a language I write a lot. This is more of a target language for translation. So I knew what I want for translation. And if you have something which would be helped, you actually want to try to use it, but you would prefer an object interface, actually come afterwards and let's talk. Because if there is a task and if there is a use case, then we can discuss what is a good object-oriented wrapper for this. I just don't have a feeling how I would structure it without a use case. And then the thing I have demoed is QueryFS. So there are actually below all these some plugins to parse the queries. Then for each query, the plugin outputs the code, which is actually exactly the same as the code you have seen in the first case, because this plugin is just passed through. And then this code gets macro expanded and compiled and stuff. Then the complete file system definition gets glued together from these translated queries. And the queries can even be updated without remounting the entire file system. You can just update one query, and then just a subset of the file system disappears and gets reinitialized. So that's what it. And when I say that the plugins define the parsing, of course, on one hand, you are welcome just to write whatever parsing you want. On the other hand, maybe this parsing you want is already commonly spreader, and then you do as with the first example. But if you want to define an DSL, I found nice to use ESREP, and I also wanted at some point to have just implementation-independent grammar syntax. I liked portable expression, parser expression grammars, and I implemented a wrapper for ESREP to generate things from such grammar notation, and then to have the CL unification and have the helpers to process the syntax trees after parsing with code like this in the matcher. So how does it work internally in practice? That okay, so the QueryFS sees that there is a query and feeds it to the plugin. Plugin returns the top-level query code. And then at some point, the kernel, which has mounted the system, gets a request from the client program. So you get a request from, so it's noticed as /QueryFS is just the mount point. So it starts feeding the parts to the QueryFS, first /query, so it knows that it needs this query code. Then it says /a, and it asks the top-level code to produce code for /a. And then this code for /a gets asked to produce code for /a/b. And then code for /a/b gets asked what is the content of the file. And then the content gets relayed all the way back to the client program. OK. My remarks on why you should care and why file system interfaces are sometimes actually a nice choice for integration. I hope that many of us, and judging from some discussions in the community, it seems that many of us are indeed, many of us are interested in both flexibility and kind of stability, that things don't churn from today to tomorrow too much. Or at least from now to 5 minutes later, already a bonus. And so if you have CFFI, on one hand it is nice. On the other hand, you have some integration issues that you need the integration to be supported on both sides in the same way, in the sense that if you want to provide some rather basic in terms of interface functionality from Common Lisp, you still need to plug it into some plugin interface and stuff. And you need the thing you want to use it to have a plugin interface which fits what functionality you want to provide. It is sometimes like that, sometimes no. Then you have the fragility issue that you need to match memory layouts, and you need to match ABIs you use when linking and things like that just to start playing. Of course, you have the question of serialization of data representation. The structure of data, the meaningful questions. But even before the meaningful questions, you already need to make sure that ABIs match and that you can describe the memory layout you want in whatever you have on the other side. You need to be careful here. And then you are running, if you are providing a library for another application, then the library will be running in the same process space. And that means you need compatibility in terms of process compatibility. That means you need to have compatible ideas of what signals are, what memory allocations are, what threads are, how these things are managed, and whatever like that. I have actually stumbled upon this even implementing CLFUs, but it's easy to work around when you are doing just one thing. But if you want to integrate with a lot of things, then you need to be sure that you are compatible with each of them. And so if you are looking on this from the point of view of file system interface, yes, you need the other side to implement the integration on their own. But maybe they already have some kind of file loading, file browsing. There is actually a chance, at least sometimes, that they already provide enough of browsing and integration that you can work with this. And they usually provide something similar between each other. So when I browse stuff in Firefox, when I browse what I will attach to my email in Thunderbird, if I handle it in Thunderbird, but whatever, or when I browse what I want to open in my graphic editor, it's all similar file browsing.
I'm Andrew Sengel, and I'll be demonstrating
okay, and actually there are a bit higher chances to support file browsing than to support HTTP APIs just right for the task you want, unless you actually negotiate with both sides and get back to this synchronize both sides task. Also, of course, you still need serialization, but if you have two processes, you will end up needing serialization. And even if you have just two code bases, you need to negotiate about the data formats. True. But on the other hand, at least, if we are talking of the lower level part about how these memory layouts work, you are working with file system API on both sides. Breaking file system API is discouraged, sometimes discouraged in rather strong words, which helps in terms that you have a hope that the other side indeed won't break the file system API. Also, right, you are running things in different processes, and that means that you don't need to have exactly the same signal handling. As long as each process does something reasonable, you can make it work because you are different processes. You don't have too much synchronization. Okay, yeah, okay, sure. There are costs for it, because if you want best performance when you have this in the same library, sure, you have better performance. You have some request overhead just because you have process switching. For cases similar to what I wanted, for cases like where SQL database request is considered acceptable cost and even negligible cost in comparison to the actual work this request will be doing, or whatever your program will be doing. For these cases, something which is comparable just to empty SQL database requests in overhead is acceptable. If you consider that an empty process switch is very expensive for the task you want to have on your interface, on your integration, then sure, nothing via Fuse will be good for you because you have full process switches, multiple full process switches. It's unavoidable by definition. So yeah, I don't deny there are drawbacks here, but they are all often tolerable. And there are, of course, some remarks on implementation, some remarks on what you are forced to pay attention to from time to time. If you are just considering playing with file system API, of course, you need to make sure you have some idea how you treat file names, for example, how you treat file contents. For example, do you expect that all file names must be valid UTF-8? Because at least on Linux, it can be just a valid string, any valid string of bytes, except 0 and slash. 0 byte, I mean. Digit 0 is fortunately allowed. So yeah, but I just assume in many places, at least in the high-level QueryFS code, in the lower level it's a bit more flexible, that, yeah, you can just assume UTF-8 or go away. Yeah, if you want something different, well, you can do this, but then you have to specify your expectations. And maybe, yeah, I'm willing to discuss it in the QueryFS. Also it's a simple way to use Fuse. There is a framework in Fuse. Well, I tried to use it. It has ideas about threads. Remember what I complained about threads? Yeah, it has ideas about threads, so I couldn't use it. I use medium level, which does all the parsing, which does all the dispatching, and that's it. But yeah, on the high-level framework, you just cannot use and don't try if you want Common Lisp or anything with garbage collection or whatever. Yeah, one step below, you have actual functions and a ton of callbacks, which works perfect. You do want to exit once the file system is unmounted. As I said, if you have things in a single process, you have a ton of gotchas. Just give up and exit once your file system is unmounted. Yeah, had issues here. And yeah, there are symbol versioning issues in libfuse. I tried to solve them in CFFI, gave up, and just wrote almost literally one-line library in C just to link correct function. And yeah, so how do I use it every day? Yes, I use it to index the stuff fetched by FDM, what I said about Unix process boundaries, in SQL, and then read it in text editor. I use it to fetch feeds from Planet Lisp, Pork, and whatever else. Notice, at some point I tried to have the fetcher and the file system in the same process. It was suffering. Don't mix network gotchas with file system gotchas, please. And yeah, password manager wasn't a good idea. I implemented file tagging because people say it's cool for organizing files. I didn't enjoy using it and gave up. Yeah, so what is not there maybe yet? There is no security model, but only same UID is allowed to make requests to Fuse file systems unless you override it, so it's not a big problem. I don't have an advanced FS functionality like Notify and map and whatever, and I don't have semantics for mixing it with SQL databases. I don't have smarter caching based on lower level Fuse API, and neither do I have in Lisp Fuse protocol parsing. Both are feasible, but both are work, and I haven't done it, sorry, but maybe if you want to work together. And the 9P, which is another file system protocol, which is relevant for VMs, not there, sorry. But again, maybe if you have if you want to work together, yeah, then I'm interested to work together. Thank you very much for your attention. Right.
So if I understand, you can expose anything you want through the file system.
Yeah.
This could, for instance, can you show using, instead of Firefox, the Explorer or how it's called on the Mac? I don't know.
Well, a file manager, yeah, I could have used the file manager. I just needed to pick one program, not to overload stuff with the showing off of GUI on Linux or stuff. Yeah.
Okay, the next question would be, can you actually do queries directly using the file system notation, like using some question mark and then selecting something, or must it be part of the module?
I write down the queries, and you mean can I? If you talk about question marks and stuff, it's actually expanded in the shell. So as long as file system is listable, the parts that are listable will work in shell. But 1, 2, 3, 4, 5, up to 10 will be expandable. 100 won't be because it's on the fly. It's not in the listing. If that's what you mean. Yeah, and I don't think, if you talk about the queries inside the file system, then, well, they need to be written down, and you have to define the language for writing them down. That's a separate issue from wildcards.
So it looks, since there is Postgre, SQL, I mean SQL, this is like a model for the file system. And so SQL would be the model and the file system would be the view, but how do you write the controllers for, if it's MVC, you have a controller to map the routes to the data?
Well, the database is the model. The controller, as I have, I think, shown here, the controller is just, well, this glue around SQL queries. So the controller is this update test table set content equal to data. Or I can write a different query language and different Lisp code to have a different controller.
So is it also writable in Common Lisp?
Yeah, because here you have just Common Lisp filling some slots in the macros with funcs, with the code in the slots of the macro. So yes, you can write in Common Lisp if you prefer.
Okay, thank you.
Any more questions? I have a question.
Yeah.
Or comment. I think it's a nice idea, and it could be used for scratch padding or for logging. So say you write a complex program, and you want to know what's going on.
Yeah.
So all you do is you plug in your library or whatever, and then you have a quick logging system that would allow you to see what's going on.
Well, not logging, it's more of inspection. Yes.
Yes, you can write whatever information quickly and browse it quickly.
Yes, yes.
Without defining the database.
Yes, that's what I meant with the line Lisp data structure as a file system. Yes, thanks. Thanks for the